Hi everyone. Today we are covering understanding statistical inferences based on Chapter 9 from Macmillan. Here you see an overview of the topics that will be covered in this video. Before we get into that, let's just do a quick little review with a couple of questions to see if we've all read and understood what we read. First up, inferential statistics enable the researcher to do which of the following? Now, the key to these questions is to try to choose the most appropriate answer. Because if you look at these four options, they all seem pretty reasonable and seem like a pretty close match to what we read in Chapter 9. But the most correct answer is C. Use sample data to make generalizations about the population. This is the most correct answer because making inferences in statistical analysis is really about making inferences in terms of connections between the sample in order to make generalizations about the population. Next, when using inferential statistics, it is recommended that you do which of the following? D is the most correct answer. The reason being, as we read in Chapter 9, is that sometimes we misconstrue statistical significance in a study for really being something meaningful. But at the end of the day, we also need to look at practical significance. And this is something that Macmillan really stressed and emphasized in Chapter 9. Okay, so an overview of inferential statistics. I'm not going to read these. I try not to do that as I've done these videos for this course, but just kind of hitting some high points. Again, inferential statistics is all about making inferences about the population based on the sample, where the sample represents an estimate of the population. Inferential statistics reflect specific procedures that are used purely for the purpose of making inferences about the population. And the ultimate goal is to attempt to make accurate conclusions about the population. And by thinking through and addressing practical significance is really where we make some of our most strong connections to the population. If this were an in-depth stats course, which luckily it's not, luckily for all of us, we'd be spending a lot of time calculating errors and looking at the types of errors that are present in inferential statistics. And as Macmillan highlighted, there are two forms of errors in inferential statistics: sampling errors and measurement errors. And so I'm just going to leave this slide up here for you to get a sense of. Again, as I've done with other videos, I'll post the static PowerPoint slides so that you can review them in detail. There are also some additional slides that are not included in this video for a little bit more detail. One of the issues we run into with measurement errors is we have problems when it comes to be able to assert validity and reliability for our study. As we've looked at previously this semester, validity and reliability are critical in particularly non-experimental quantitative designs because we want to be able to make a strong case for our findings to be generalizable to the population. And if we are unable to demonstrate validity and reliability, we really have a difficult time in making any sort of suggestion of generalizability. Lack of validity and lack of reliability are a couple of key flaws that really stop a research study in its tracks. Macmillan addressed some terminology that's used regarding inferential statistics. So the first is the null hypothesis. And when we write a null hypothesis, we're basically writing the opposite of what in our minds we want to find. But we actually test against the null hypothesis. So we conduct inferential statistical tests to determine basically whether or not there actually is a difference. And so we write that as there being no difference between groups or no relationships between variables in the case of a correlation analysis. We look at level of significance, and this is addressed as alpha. And alpha is expressed in a range of 0 to 1. And so the closer to 1 that an alpha is reported, that means that it's a higher level. I'm sorry, backwards. The closer to 0 is a higher level of significance. So this, you may see this as 0.001 or something like that. And then types of errors. Type 1 errors comes about when rejecting the null hypothesis when it is true, and type 2 not rejecting or accepting the null hypothesis when it is not true. Most research articles do not actually report type 1, type 2 errors. Sometimes when those come about, the researcher retools the study because ultimately we want to avoid type 1 and type 2 errors. So I've already mentioned, and as I said, Macmillan went to a great length in Chapter 9 to address practical significance and the relationship to statistical significance. So statistical significance is all about an estimate of the probability of being wrong and rejecting the null. So this might be reflected. You've seen this in the book as reflected as a normal curve, where the tail ends of the curve reflect, or the tails reflect our probability of rejecting the null. As mentioned previously, type 1 and type 2 errors, I mean, they're always there. They're always a possibility. But it's one of those things that in terms of being a consumer of research, it's good to have an understanding that they're out there, and it's something that researchers address in their work. But it's probably not something that you're going to see reported. In fact, I can't think of anything you've come across this semester for this course where you would have seen type 1 and type 2 errors addressed in a research article. And Macmillan spent some time addressing factors that affect the level of significance. And so these might be actual differences between groups in a study, the extent to which sampling and measurement errors exist, and then also the size of the sample. Generally speaking, the larger the sample, the less likelihood that we're going to come into any of these errors, but obviously most specific to sampling errors. Practical significance is really about the usefulness of results of a study. So as I mentioned, statistical significance, that's a goal of measurement that we work towards as researchers. But practical significance is really what we need as consumers of research. And so for me, a really done research article in an applied field like education is one where the author has done a really nice job of making clear connections from the statistical significance to practical significance. And one of the ways that some researchers, and this is a growing practice in educational research methods, one of the ways that researchers go about attempting to demonstrate practical significance from a research perspective, not just through making inferences and practical implications, is through the calculation of what is known as effect size. And so I've put the formula up on the screen, not because you're supposed to know formulas in this course, but just to demonstrate for you how this is calculated. So calculating and reporting effect size provides a way of taking variance into account. Effect size would only be presented in a study that involves comparisons between two groups or samples, so you won't find it in every study, and you shouldn't. But this is one thing that, as I've mentioned before, I serve on as a reviewer for some journals and in other capacities for some academic journals. And I do see some reviewers suggest that every quantitative study should report effect size, and it's not realistic. If the sample was of a single group and it was not a comparative sample type of study, then there's no way to calculate effect size. And so what this formula represents is that in the numerator we have the sum of the means of group 1 and the sum of the means of group 2, and the difference between those divided by the standard deviation as a whole. So that gives us our effect size. And effect size is really a way of suggesting, hey, look, this is a really strong effect size for the comparison between these two groups. There's a strong likelihood of practical significance for this study. So on this slide, want to just think through an example really quickly. Each consumer of the research must judge the balance between the statistical significance and the practical significance of the statistical results given the context in which the results might be used. So as we think about practical significance, we need to think about how are you evaluating practical significance for your papers. So as you're working on your MRP, and let's say that you've got comparison groups, and not just in terms of you're going to say that you would end up calculating effect size, but think ahead. How do you think you would make those inferences to try to reach practical significance? Rather than getting into the nitty-gritty of some of the different forms of inferential tests in this video, I'm going to just leave that for you to review in the PowerPoint so that this video doesn't go on and on and on. So we're just going to leave it as an overview of some of the kind of big picture elements of inferential statistics with emphasis on practical significance and statistical significance.